Excellent. Okay. Well, I guess it's my turn. Welcome, everybody. I'm Wierschem with the Keep Calm and Refactor project. Let me go and share my screen here. Boom. And go to my slides. My session is called How Do I Test This Mess? And this is my contact information. Um, so basically, I just wanted to say hello, friends. Welcome to this presentation on adding tests to legacy code. I'll be your Bob Goff and show you that you can do this. I'm going to show you a few simple techniques that, as you apply them little by little over time, your code will become a work of art. Okay. So now we all know the steps for doing TDD, right? We quickly add a test, we run all the tests and watch the new one that we just added fail. We make a small change to the code. Then we run all of our tests and see them all pass. Then we go through and refactor it. So when we write code, this is the one process that we should follow. But what's the step that we usually skip? It's this last one. Yeah, it's the most important one. I've been thinking about this a lot lately. I work on an agile team. We follow a Scrum method, and my other team members are evaluated on their ability to deliver and maximize the number of dones that they have at the end of the sprint. So we all have this pressure to get our feature added, make sure the tests pass, and it's good enough if the test pass, so move on. So we really don't spend the time we need to refactoring. So we tend to start building a mess. The refactoring step is a really important step in both maturity and in teamwork. So you need to make sure you take some time, look at what you did, and then see if there might be a better way. Now, one thing you might try is to go ahead, check in your working code, but then start from scratch. Do it a different way. Now, this is also the step where you will consider how other people will be using the code. Make sure that it's easy to understand, easy to read. Do you need to rename something? Is there something you're duplicating that you could turn into a function call? The bottom line is do not skip this step, all right? So that's our wonderful TDD process, but what about when you're supporting a legacy system, right? After all, that's what most of us do. In my career, I've worked on 2 projects where we wrote something from scratch, and they quickly devolved into a mess. So let's look at the TDD process when we're debugging existing code rather than creating something new. So first we're going to add a test, and adding a test to legacy code may not be so quick. And then we will run all those tests and watch the new one succeed, because the way it currently works is effectively the right way, because that's the way it's running. So if there's a fix that you need to make or an enhancement, you'll make a small change to the code reflecting the desired fix or a step to implementing that fix. Then you'll run all the tests and see the new one fail. And if it doesn't fail, the test is wrong. Then we'll update the new test to reflect that change. We'll run all the tests and see them all pass this time. Okay, and then finally, we'll go and do that oh so important refactor step. Okay, now for today, our reference is going to be the very excellent book, Working Effectively with Legacy Code by Michael Feathers. If you don't have it, I cannot recommend it highly enough. His approach in this book is to respond to situations like, I need to change a monster method and I can't add the tests, or it takes forever to make the change. So it's like a recipe book for all the problems that your systems could run into. And one of the things he mentions in the book is the concept of code seams. This is a way to insert a test or the ability to test code without changing the functionality of the application. So let me show you a couple of quick ways to implement technique of creating seams in code. This is a method that I learned from a guy named Llewellyn Falco. He's a really sharp guy, and he calls this the peel and slice. So imagine you have a method and some code at the top is untestable for some reason. Maybe it does a database access or does some UI or something like that. You want to be able to peel it off into a separate function. Excuse me, I've got a little bit of a cough here. And then you want to put the rest of the method under test. Okay, now the slice is similar. You have some untestable code in the middle of the method. You want to be able to override the function there with a fake, and that will allow you to control the state of the method with some dummy data, and then you can make it testable, right? So let's look at the example code here. This is a very contrived example. What we have here is a customer data access object, and it runs vital functions for this data access object. We pass in a customer ID, and it will load the customer from the database. Based on that customer ID, we get a result back from the database. We process that result set. It's very complex, so I've left it out here. Then we go and we set today's date based on that customer data that we get out of the result set, and we get a change ID back from that. We do some more processing, and then we return that change ID. So our problem here is that this load customer from the database is a database call, and if I'm trying to write a unit test, my customer ID may or may not be there, my database may or may not be there, and I'm going to have problems with my unit test running very, very quickly. We generally want our unit tests to run, in microseconds, milliseconds. So if they run as quickly as possible, then we will run it more often, and we'll be able to follow a test-driven development method. So what we'll do is to try and peel this function at the top off. And the way that we do this is we will take this part, the data processing, and just turn that into a function that we call process result set. Okay? And we'll keep the same function signature where we pass in the customer ID, and we will keep that load customer from database, and we'll pass that result in to process the result set, because really all we need is the result set. Then when we create our test, we'll create a dummy result object and pass that into the process result set so that we know what the state is of the object being passed in, so we can know what the state of the function will be and test that. So basically, we've taken this process result set function, and you can see that I basically just copied these 4 lines of code into here. So I haven't changed any of the original functionality if I call this customer ID. But what I've done is I've created a seam here by breaking this out into a separate function so that now I can run a unit test on this code by just stubbing out or creating fake data for this result set. And this is what that test would look like. We'll create a new test customer, and we will have we'll call this test result. We'll create a new test result object based on this test customer, and then we'll create our customer DAO that we're wanting to do the test, and we will then pass this test customer into the test DAO. Actually, we'll have to pass the result. I'm sorry, my slide is wrong. I need to pass that result into the run vital functions method and make sure that it returns the function, the result that I expect. And we have successfully peeled off that function at the top that was untestable, and now we've made this method testable by doing so, while also not changing the functionality of the original application at all. That's one of the beauties of creating a seam in the code. Well, now we've got this problem here, this code in the middle. How do we go and mark that off and make it testable? Well, we will go through, we've got our process results set, and basically we're setting today's date in the middle. And the problem with dates is they change every day. So what I want to do is find some way to create a seam right here in the middle so I can have control over what this date call is. So what I will do is I will create in my test DAO, I will extend it and I will overwrite the method for set today's date. So I'll create a test customer DAO that extends the customer DAO. This will override the set today's date function here that we're calling, and it'll pass in the same customer data. We'll have our calendar, we'll set the date to a date that we're interested in, and then we have the rest of whatever processing code is in this set today's date, and we'll return 99.99. Because this function of set today's date is not really what I'm testing. I'm really testing the processing and the pre-processing and the post-processing of that, right? So, so basically I'm stubbing that out with some fake data. And then the way that my test works is I will create my test customer, have my test result based on that test customer. I will now create a test customer DAO, and I'll run the vital functions on that. It will go and call my test date in my test, but it won't be changed for the rest of the application because we haven't changed any of that. So it's all working effectively the same. So I haven't broken the application, but I've also made it testable in a way that it wasn't testable before. So this is a very good thing, and this is really useful. And it's a pretty simple way to do things. I recommend you do this. Now, another idea that Michael Feathers discusses in his book is that of characterization tests, where you have a class or a method and you need to make changes to it, but it has no tests. So you want to make sure you don't break anything when you make your change. For this, we'll use a characterization test. You'll write a test that invokes the method and covers every path through the code. And that way you can be reasonably confident, not necessarily 100% sure, but reasonably confident that any changes that you make aren't going to break the basic functionality of the method. They're not going to, they won't change the basic functionality of the method. You can refactor it with a lot more confidence that way. For an excellent example of this, I'm going to refer you to a set of videos by Emily Bakke. She's the one who came up with the Gilded Rose kata. Now, if you haven't heard of this, you're welcome. You'll just Google that and find it. In this particular session here, this set of videos, she shows how to put characterization tests into that kata. Let me see here. I think I've got right here is the article where she describes it. There's Emily, and I will go and put that into. I'll stop sharing here. I'll put that into the chat here for you. Right. And really, it looks like I am pretty much out of time. I will go and oh, okay. So I guess I'm off. I've got about 5 minutes left, and I went and wrapped things up a little quicker than I expected. So, does anybody have any questions or concerns? Anything else that we want to discuss on this? What I can do, let's see here. Yeah, I guess you can go talk with speakers, get some mentoring on the lounge. Yeah, go there, choose a table. and join the conversation. That's what Bruno just said. So very good. I've put the link in here to this other session, and I've got a raised hand. Let me see what we got here. So no hand mic. There you go. So
Hi, I noticed that you have not addressed coverage reports, or when do you stop refactoring?
when to stop refactoring? Well, that's really a judgment call. I mean, really, you stop refactoring when you're confident that it's in a better state than it otherwise would be. I mean, really, you can spend your life refactoring, but the problem is not that we do too much refactoring. It's usually that we don't do enough, if any, refactoring. So really, you want to aim for making the code readable to the next person who's going to be reading it. And chances are really good that that's going to be you a few months down the road, and you're going to wonder what the heck were you doing way back when. And you were talking about what was this other thing you mentioned?
Coverage reports for unit tests.
Right. Okay. Yeah. Code coverage. Yeah. That's I kind of short-circuited that. That session that I linked to from Emily Bakke, she goes over that really well with the code coverage reports. One thing I will say with respect to code coverage is that it's not necessarily a panacea. Just because you've gone through every step doesn't mean that you've just because you've got 100% code coverage doesn't mean that you really are completely testing the application. It means that you've covered at least one path through. It's just that anybody who has focused on code coverage will know that there's always that path you didn't think of that the user seems to find, and it turns up a bug. So does that answer your question?
Yes, thank you.
Okay, my pleasure. So what else do we have here? So what advice to simulate the API result for a unit test? Okay, so that is where we use that the peel or slice method that I showed before. What you would do is you'd effectively stub out that API call, and instead of actually calling your third-party tool, you would override the call to that, and in your test, you'd have a test object that overrides that method call, and then you would go and stub it out with some fake data that you have control over that will let the function run quickly and consistently. A system that I work on, basically the original author decided to create his own ORM, and so accesses to the database were absolutely miserable. So I spent some time going through and faking out the database calls, and this particular method has really been my salvation. So that's one of the reasons I like to show it off. I hope that answers your question. Goodness gracious, this font is small. These old eyes can't see it. So I hope that answers your question, Adelaide. Okay. All right. Very good. Well, it does look like my session time is pretty much over. I will go ahead and move to the lounge. So if anyone has any questions they want to discuss with me, I will be there. Go ahead and attend the other sessions. If they're interesting to you, I should be around after all the sessions are through. So I appreciate your coming and attending, and I hope you have got some value from me, and you'll get great value from the rest of the people who are presenting today. Thanks, everybody.